Guys, let's solve the problem longest consecutive sequence. This is the question. We've been provided an array of numbers and we have to find the largest consecutive sequence. So there's nothing that precedes 100 or nothing that comes after 100. So this is a sequence of length 1. This is a sequence of length 1. But here we've got numbers that are consecutive. So we've got 1, 2, 3, and 4. So the longest consecutive sequence is 4. Now the constraint here is that needs to be solved in O of n complexity. Otherwise, we could have simply sorted it, and once we had it sorted in n log n time, we could have it iterated through the array, and that would have been an easy solution. But that would be an n log n solution, so is not applicable. The trick in this one is that we have to find the starting point. If we are able to find the starting point of a sequence, and then we are able to search whether there's a number that comes after it, and if we are able to do it in O of 1 time, then we can get an answer in O of n time for the solution. Meaning, let's say if we convert this array into a set, and then if we go on look for the first number 100, and we see, is there a number that is one less than 100, meaning 99, that is available in the set? Now why are we looking for that? Because we only want to increment, we only want to count this length of the sequence starting from the first number. So if there was a 99 that precedes 100, then 100 is not really the start of a sequence, so we should not be counting the length from 100. We should in fact be counting it from 99. But once we determine that there's nothing that precedes it that's in the array, that's when we know this is the start of a sequence. So in this particular instance, there's nothing that comes before it. So the length will be incremented. It'll be set to 0, will be incremented to 1, but we don't find anything after the fact. So the length would be 1. Now, what will happen to 4? Well, with 4, we see that there is a 3 available in the array, so we'll not start our counting yet. With 200, we don't see a 199 here, so we can start counting our length. We'll not find a 201, so that means the length will be 1 eventually. With 1, we'll see if there is a 0. Well, there's no 0, so we'll start with 1. We count the length as 1, then we'll see whether there's a 2 in the set, because we had already translated transformed it into a set. So we'll see whether 2 is there. It is. So we'll increment the length by 1, and then we'll find 3, we'll find 4. Well, 4 is already there. So that's that. But when we search for 5, 5 is not there, so the longest length would be 5, would be 4. Now, the reason this is O of n complexity is because we iterated through the entire array. We checked each and every element, but the thing is we were able to check it in O of 1 time because we had already stored this array as a set. So that is the solution. Let's get coding. We'll just make a num set, and this would be a set of nums. So basically what we are doing is we are passing this list into a set and we are calling it num set. Initially the longest, because we have to get the longest consecutive sequence, so this is 0. Now we'll say for n in nums, if n minus 1 is not in num set. Oh, what does that mean? That means that if the value that is one below this, if this is not in num set, that means that this is in fact the first value, and we have to be sure this is the first value before we start counting the length. So if that is the case, then we'll say initially the length is 0, but while n plus length. So initially it's 0. So what would n be? What would this expression be? It would be n plus length, meaning while n. So for the first one, it would always be true if it came down until here, because so we'll say if this is a num set, because here we came down here because n is in nums. So this for the first iteration is redundant, but where it becomes useful is if this does happen. If this does work out in the first iteration, then we'll increment the length by 1. So now that the length has been incremented by 1, it will check if n plus 1 is a num set. So now it becomes useful. And if n plus 1 is in numset, then length becomes 2. If it is not, then it will break and length would remain 1. So that is the thing that we have to do. We have to go on counting the length until the elements are consecutive. And then once we have the length, how would we update the longest variable? We'll say max of what it already was and whatever this new length that was calculated. And now we can return. So this is a trick question. We use the set to do a constant lookup, and because of that we were able to get an O of n solution overall. Let's run this.